We're going to actually do this in two parts. We're going to talk about all the characteristics of functions we've studied so far. We're going to start with linear functions because that is the heart of the first part of the unit that we just got done with. And then we're going to do the part two is going to be the nonlinear functions because there's some differences with those that we want to make sure we're making close attention to. And we're going to do these in order for the most part, but we may skip around the table. So the first two functions we had is linear, and we started with this guy right here. Now, many students noticed that they could see points, and they said, do those points matter at all? No. Those are what Mr. Fossum drew so he could draw a fairly straight line. They may actually do that to you on a test, though. If you have arrows, and we're talking about characteristics, those points become pretty moot, right, on a linear function. So we're going to start with domain, and the directions clearly stated inequalities. So I have to write as inequality or it would be wrong. So my domain is going to go from left to right. This guy is pointing all the way to the left, and this one's pointing all the way to the right, which means it's going on forever to the left, which is negative infinity, is less than x, is less than infinity. Huh. Yay. Way to start off. That's an infinity symbol, a beautiful one I might add. All right. I was already thinking ahead, which is always a scary thing. This is another way of saying x can be all real numbers. X can be any number that you've learned so far in the world. Okay? Yes, ma'am.
Okay, so you know how like with the normal, we normally go like with the clothesline. Why isn't it a line other than the phone?
Why isn't it? Because you can't actually hit infinity. It's not an actual number. So whenever, just like when we did interval notation and we said it can never be a bracket, with infinity it can never have the line underneath it. Great question and great point to bring up. And that's exactly where that needed to be brought up. So our range on this then is how far down and how far up. But what's the biggest difference between domain and range that I'm about to write here? It's a y, not an x. It's still going to be negative infinity to infinity because it goes forever down, forever up. But it's going to be a y because I'm talking about range. What's the other thing you could have put here instead of a y?
Y. F of x.
F of x. Either one would be fine. All right. The next two things that we're talking about are x-intercept and our y-intercept. And so we'll start with x-intercept. That goes on the x-axis, which is right here. That looks to me to be like about negative 1.5, comma 0. Please write it as a point. I'm going to even put that on the quiz as a coordinate point. And the reason being is it helps me remember that you know that y has to be 0 here, right? It's just that way to connect it to the equation, to connect it to everything. And then we'll go ahead and we will do the y-intercept. All right, and I'm going to put a y right there since I'm using the same color. And that's going to be the point 3, comma 0. I'm sorry, 0, see, that's why we're doing it, 0, comma 3. So there's my x-intercept, there's my y-intercept. That looks so ugly, I just can't live with it like that. So we'll use just a little bit of magic. All right. I think that made it look worse, but that's fine. All right. I didn't need your agreement on that at all. Now we're going to do increase or decrease. So let's look at this function. Does it increase, decrease, both, or neither?
Increase.
It never goes down. If I start here at negative infinity, Pierre is only climbing. That's all he ever does. We don't look at the arrows except that we know it goes on forever. So Pierre, that ant, yeah, it went a little off the line. He is climbing. So we're going to say it's an increase, and the way we write that is, remember that these are always the x values. Always the x values. So it's increasing from negative infinity to infinity. We could have also in words said it's increasing over the whole domain. That's a fancy math way of saying it never decreased. Okay. Not if I say inequality. If it's open-ended and I didn't say it, that would be a great thing to say that. All right. What am I going to write for decrease then on this particular one? NA, no answer, none, not applicable, whatever to let me know that it's not. Let's hit extrema real quick first. Is there any?
No.
No. There's no minimum because it goes down forever. There's no maximum. Here's a little trick for you. If your range has no floor or ceiling, then you will not have a minimum. Okay? Or maximum. So if you don't have a number here, and you don't have a number here, you have the infinity symbols, you don't have an extrema. And we'll discuss that again as we go through. Our last thing is in behavior, which literally means the two ends of the function, the left side and the right side. And we always start by immediately saying my left side as x approaches negative infinity, and my right side as x approaches positive infinity. That is always how I start this. Always. Now let's go to the left side. F of x has got to be doing something. What does f of x got to be doing? It's decreasing or going down. And how do I say that in math? It's approaching negative infinity. On the right side, what is it approaching? Infinity is correct. And those are all the characteristics for that linear function. Now we are going to move to the second linear function that you were given for homework. And this time I asked you to write it in interval notation. It's the same information, just in another form. It's like writing something as a fraction versus a decimal versus a percent, right? Same value, same thing, just a different description. So the domain for this one, again, I'm going forever to the left to right. So in interval notation, I'm going to write that as negative infinity, comma infinity with parentheses. Again, just as it was brought up on the one before it where we didn't have the equal to part, we do not have brackets because you can't ever hit infinity. Now this one is a little weird because it doesn't actually make me tell that the range is the y values. The range is going to look the same way. Negative infinity to infinity. There's no x's or y's when we do interval notation. They assume you know that domain is x. They assume you know range is y. Okay? And I want to point out on any linear function that has arrows on both sides, that's always going to be your domain and range. You've probably figured that out by now. You probably have. The only thing that's going to change it is if we have a line segment instead of a line, right? If we end it somewhere. But we didn't end these. Which means what's going to be true about extrema? There is none. We can go ahead and fill that in right now. Now, we'll go ahead and do our x-intercept. And our x-intercept is at 1, 2, 3, 4, 5, 6. So negative 6, 0. I will caution you, be careful. I've seen a lot of students count to 6 and they forget to put the negative when it's on the left. Okay? And my y-intercept is down. 1, 2, 3. So 0, negative 3. Does this one increase, decrease, both, or neither?
Decrease.
It's decreasing. Pierre's sliding forever. He just slides, slides, slides. Okay? Whee! Remember he said whee! I don't really want that on video. Alright, so in A up here, because it never increases, and it's going to decrease from negative infinity to infinity. Now, again, when we get to our in behavior, before we even think about it, we do our left side and our right side. Because no matter what, it has those. And on the left side and on the right side, y is going to be doing something. So let's start with the left side. On the left side, what's happening? It's going up, so it's approaching positive infinity. And on the right side, it's going down, so it's approaching negative infinity. With a linear, you'll always have one of each. With a linear function, you'll always have one of each on the f of x. It's the only one that I can guarantee that one on.